Hi, welcome. This lesson is on factoring out the greatest common factor, GCF. So the greatest common factor of two or more integers is the largest integer that is a factor of all the integers. So let's take a look at that over here with 24 and 60. So the way we would do this is we could say, I'm going to write 24, and then I'm going to start with the smallest prime factor, which is 2. And 2 goes into 24 12 times. And 2 goes into 12 6 times. And 2 goes into 6 3 times. And because 3 is prime, we stop there. And so then we're going to do the same thing with 60. We say 60. 2 goes into 60 30 times. And 2 goes into 30 15 times. Now 15 is not even, so 2 won't go into it. So I go to the next prime number larger than 2, which is 3. And 3 goes into 15 5 times, and 5 is prime. And so we're finished. So then I just say, well, what do they have in common? They have 1, 2 in common. They have another 2 in common. And they have a 3 in common. And so their greatest common factor would be 2 times 2 times 3. And that would be 2 times 2, 4, and 4 times 3 would be 12. And so their greatest common factor is 12. Let's take a look at that. With, if you have 3 numbers, same thing applies. So we go, So we go to 45. And 2 won't go into 45. 3 will. 3 goes into 45 15 times. And 3 goes into 15 5 times. And then we'll do that same thing with 81. And 3 goes into 81 27 times. 3 goes into 27 9 times. And 3 goes into 9 3 times. So there's the 4 threes, or 3 times 3 times 3, 4 times. And then we look at 117. And 3 will go into 117. It goes in 39 times. And 3 will go into 39 as well. 3 goes into 39 13 times. And 13 is prime, and so we're finished. And I see, what do they have in common? Well, do they all have a 3? They do all have at least one 3. And do they all have another 3? They do all have at least one other 3. And that's it. That's all they have in common, is the 3. So the GCF is 3 times 3, or 9. All right. If we look at the next definition, it says that the GCF of 2 or more monomials is the product of the GCF of the coefficients and the common variable factors. All right, let's take a look at what that looks like here. So 24x cubed. So we're gonna get 24, and that goes into 24 12, and 2 into 12 6, and 2 into 6 3 times. 56, 2 goes into 56 28 times, and 2 goes into 28 14 times, and 2 goes into 14 7 times. 7 is prime, so we're done with that one. 4, 2 goes into 4 twice. And then 12, 2 goes into 12 6 times, and 2 goes into 6 3 times, and 3 is prime, so we are finished. So I look and I say, hey, they all have that 2 in common. And then I ask myself, do they have another 2 in common? And they do. They all have another 2 in common, and that's it. So you multiply 2 by 2 together, that's 4. But if I look at the 24x cubed, I can write that as 2 to the 3rd power times 3 times x, x, x. And 56x to the 7th, I can write as 2 to the 3rd power times 7 times x, 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 1, 2, 3, 4, 5, 6, 7. And 4x to the 8th is 2 squared times x, 1, 2, 3, 4, 5, 6, 7, 8. And 12x squared is 2 squared times 3 times x, x. Now, we've already decided that for the coefficients, they have 2 2's in common. So the GCF, 2 times 2, when I look at the variables, they only have, we're limited by the one who has the least, so there's 2 x's here. They all have at least 2 x's, but they don't have more than that. Because of the 12x squared, it doesn't have more than just the 2 x's to contribute to this common factor. So this is x times x. And then we just multiply that together. So the GCF is 4x squared. All right. So what does it mean to factor? It means to write an expression as the product of its factors. Okay, we factor out the greatest common factor. If the leading coefficient is negative, factor out a negative. If the polynomial cannot be factored, write prime. So look at this first one. We've got 6x to the 5th minus 8x cubed plus 4x squared. And then in our solution, we've got the GCF of 6x to the 5th, 8x cubed, and 4x squared is 2x squared. When you factor out a GCF, you're undoing the distributing. Distributing is multiplying each term, so factoring out the GCF, or the greatest common factor, requires dividing the GCF out of each term. So 6x to the 5th minus 8x cubed plus 4x squared. If the GCF is 2x squared, you have to say, what would I multiply by 2x squared to get 6x? What would I multiply by 6x squared to get 6x to the 5th? And 2 times 3 is 6, and x to the 3rd times x squared is x to the 5th. So that's that part. And then minus 4x times 2x squared would be negative 8x cubed. And 2 times 2x squared would be 4x squared. All right, let's look at what this looks like in practice here. Y squared is y times y, and 2y is 2 times y. And then I say, hey, they both have a y in common, so that would be their greatest common factor, because that's the only thing they have in common. And so if I take out their GCF, Well, factoring using GCF is I take out the y, and I'm left with, in the first term, y, and for the second term, I'm left with minus 2. And so this is the factored form of this polynomial. And if you wanted to do the check, if I multiply y times y, I would get y squared. And y times negative 2, I get negative 2y. All right, let's look at example 5. We got 12z to the 5th plus 36z squared. And look at that, 12 and 36. And instead of doing the prime factorization, which you still can do, it's a little faster if you recognize that one is a multiple of the other. 36 is a multiple of 12. And so they're going to have that 12 in common. And then they're limited by 2 z's. Even though this one has 5, this one only has 2. So they have 2 z's in common. So their greatest common factor is 12z squared. And then I'm going to write, okay, 12z squared times z cubed would give me 12z to the 5th. And 12z squared times 3 gives me the 36. And then that's it. So there's my common factors, the 12z squared. And the parts that are left, I'll do those in blue, z cubed and 3. And so what stays inside my parentheses is z cubed plus 3. And what I have on the outside of the parentheses is my common factor, 12z squared. All right, let's take a look at this number 6. 4x plus x squared. Okay, I can't take a 4 out of both of them, so for the coefficients, what they have in common is 1, but that doesn't help us any. Taking out a 1 wouldn't change it any. But they do both have an x in common, and so my GCF is x. So I'm going to write x times 4 plus x times x. And then mentally I'm going to do what I'm highlighting here. I'm going to say they both have that x in common. So that I'm going to take out x times 4 plus x. And that is factored. All right, 15x cubed minus 9x to the 5th y. And here, I know that 15 is 3 times 5 and 9 is 3 times 3, so they have a 3 in common. And they both have at least 3 x's, so x to the 3rd power. And I think that's it. So I'm going to write the first term as 3x cubed times 5. 3 times 5, 15. And x, nope, no x, because I already have all 3 x's in that first part. Minus 3x cubed times, and 3 times 3 is 9, and x squared times x cubed would be x to the 5th, and then I also have the y. And once again, I'm going to say, okay, this is what they have in common, so that is what I'm going to factor out. I'm going to write it as 3x cubed times 5 minus 3 3x squared y. And that's what this looks like in factored form. Remember that, it's just the same as like if I said to you, hey, factor 6, and you say, well, okay, that's 2 times 3. And this works in both directions, right? 6 factored is 2 times 3, but 2 times 3 multiplied is 6. So if you want to see, did I do this right? If you just multiply it back out, you should get the original polynomial you had. All right, 8. Example 8. 7 is prime, and neither 12 nor 19 are multiples of 7. So the only thing they have in common as far as their coefficients would be 1. And then I look at the first one, and it has x's, but the second one does not have x's, neither does the third. So the only thing that they all have in common is 1. So this is one of those examples that says if the polynomial cannot be factored, write prime. And so in this instance, we can say this is prime. The only factor that they all have in common is 1, and factoring out of 1 would leave them exactly the same. All right, example 9. We've got negative 4a to the 6th, b to the 4th, 8a cubed, b to the 7th, minus 2a squared, b to the 5th. And the smallest coefficient they have is 2, and both 4 and 8 are even, so they have a 2 in common. Our leading coefficient is negative 4, so I'm going to put negative 2. They all have a's, but they only all have at least 2 a's. So I'm going to put a squared. And do they all have b's? Yes, they do all have b's, and they all have at least 4 b's. So I'm going to put b to the 4th. And then I'm going to use that to write each one of these expressions, so I know what I have to multiply to get them. So negative 2a squared b to the 4th times 2 would give me negative 4. And a to the 4th would give me a to the 6th. And that's it, because I already have the b to the 4th in the common factor. So then I'm going to put minus 2a squared b to the 4th, again for the second one. And what would I multiply by negative 2 to get a positive 8? Well, a negative times a negative is positive, so it would be a negative 4 times a negative 2 would be positive 8. And a times a squared would be a cubed. And b to the 3rd power times b to the 4th power would be b to the 7th. And then one more time, negative 2a squared b to the 4th times they already have the negative 2, so I can write 1. You can write the 1. I don't usually, but I'll write it this time. A squared, don't need to add anything to that because it already has the a squared in the common factor. And then b to the 5th, so I would just write b, because b times b to the 4th would be b to the 5th, and so that last term is just that. So this time I'm going to highlight the ones that are going to stay. The ones that are going to stay inside the radical are b, negative 4ab cubed, and 2a to the 4th. And so what's going to come out of each of those is negative 2a squared b to the 4th times 2a to the 4th minus 4ab cubed minus, plus b. And then I'm going to just account for the signs and make sure that I've got this correctly here. Negative times a positive would be oops. Sorry. A negative times a positive would be negative 4. And then a negative times a negative would be positive. A negative times a positive would be negative. And so the signs are good. And then if you wanted to multiply each of those out, using the distributive property, you could see that they do give us the original there. And so this is correctly factored. All right, that's all I've got for you. Practice, 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 practice. That's the way we learn math. All right, thank you.